All right, Chris, so you can begin.
Well, thank you, Rachel. My name's Krista McGaw. I'm the executive director of Tecumseh Land Trust. We're based in Yellow Springs and work most actively with Clark and Greene counties. We're one of a local land trusts of about 30 local land trusts through Ohio. Um, we partner often with Community Solutions, which is our co-sponsor on our event today and our whole Growing Green series that is going to go for the next 4 weeks. We embarked on a community partnership, not just with Community Solutions, but with a total of 13 organizations back in 2018. We started soon after Community Solutions acquired their Agraria property. We decided to try to apply for a regional conservation partnership that is something that the Natural Resource Conservation Service has set up in the last version of the Farm Bill. And the reason for doing that was that they wanted to see local partners that might be able to bring innovations to um, outreach for their conservation programs in the Farm Bill with really the focus on water quality improvement. Clearly, that's a big issue across the nation. Our regional partnership is a part of the Mississippi River Basin watershed of the United States, and so clearly algal blooms in Ohio, Lake Erie to the north, and down the Ohio River to Mississippi are something that's a current concern for us. We were one of, I believe, about 60 partnerships that were awarded in 2018. We and our partners altogether committed almost $3 million to help with conservation practices. That's through the Environmental Quality Improvement Program, through the Natural Resource Conservation Service, also monies for permanent conservation easements um, that are available through the Natural Resource Conservation Service, but also through some of our state partners, the Department of Agriculture, Ohio EPA. Actually, we haven't done one of those, but they're available, and then also Clean Ohio Open Space. So we've had some really good progress. We'll soon have most of our conservation monies through the EQIP program committed in our Jacoby partnership. And so we're really happy that people have been very, very interested and responsive to those opportunities. We, as a part of our Jacoby partnership and our educational outreach, in large part because we have a lot of landowners in our area who are farmers and are not very familiar with conservation programs that exist, and not necessarily really familiar with other landowners and farmers in the area who might be interested in finding out more about conservation improvements that they can make that could lend themselves to better water quality. It turns out that practices that lend themselves to better water quality also improve your soil quality and can improve your productivity and can sequester carbon in the soil and help to reduce the impact of climate change. So, kind of from the beginning in our planning for this conference, which originally much of this conference was to happen a year ago in person. As it turned out with COVID, we ended up having to postpone it kind of at the last minute. But several of our speakers are folks that we had asked last year, and in this virtual format, are coming back to help us with the event this year. And thanks, shout out to Rachel here, Isaacson at Community Solutions, who is our tech guru and keeping us all together through today and then the next through 3 weeks of programming that we'll be offering. Um, we Climate change was something that was on our radar when we first started planning for the Growing Green Conference in 2020, which was not to be. The timing of this particular session this year couldn't be better or worse, depending on how you look at it, I guess. after just the real radical weather events that we had in the last couple of weeks. And clearly, we are not prepared for the severity of some of those events, and uh, being able to curb the severity in whatever way we can is just very, very important. People died. It was a very, very stressful time, and unfortunately, on top of a lot of other stresses that we face in the country with COVID and more. We're really happy today to have with us Aaron Wilson, who is an atmospheric scientist at the Ohio State University, who was slated to kick off our Growing Green conference last year. We're glad he was able to join us again. Aaron is a very, very qualified person. The thing that I want to say in particular about him is that he has explained climate change to more audiences than anybody else that I have ever encountered. I've run into him in that context in several different audiences, initially at the Kiwanis in Springfield, Ohio, on their annual Farm City Day. And he is able to explain climate change to a variety of audiences very successfully. And we really appreciate his making time on the weekend here to join us and to share his presentation, and then also to work with us after his presentation on a panel where we've got some local farmers who we really appreciate also joining in to talk about their experiences. And they have a variety of farming experiences, from hands-on vegetable farming and limited animal agriculture to a very large scale of agriculture as well. So we really appreciate everybody's time and energy going into this. And we're just delighted to have you with us, Aaron. Thank you.
Well, thank you, Krista, and it's certainly an honor to be with you today as I get the presentation going here. Certainly, like you said, meant to be with you last year, but it's never too late to talk about climate change. It's never too late to talk about its impacts on agriculture. So that's what I'm wanting to do today. Oops. Just so you know, there is a copy of the slides available to everyone here. If we can throw this up in the chat, or I will in a little bit as well. This is the tinyurl.com that you see here. And I'll go ahead and throw that in the chat real quick as well. This is just a copy of the slides that I'm going to present today. That way you can have them, because I've got a lot of information to share today, and I think it's going to go by pretty quick. So I want to make sure that I get this out to you as efficiently as possible. So yeah, we're going to talk about agriculture and climate change. And of course, I like to start with where we kind of, how do we experience weather? And, we experience weather with our senses, right? This is just a cornfield in the middle of Auglaize County here in West Central Ohio this past summer. We could probably feel the heat, the humidity, puffy cumulus clouds starting. But as meteorologists, we have to take that information and we have to translate it into some forecast maps and observations and symbols and weather maps and all of that stuff. But over time, we collect a lot of data, a tremendous amount of data, which we make different graphs and we interpret those graphs. But ultimately, I think the magic is really when we take those data, interpret them in a way that is useful for the community, from droughts and water shortages to water use and all kinds of different things that we can do. And I think this is really how I see the entire weather and climate enterprise. Now, I grew up in Miamisburg, Ohio, so I'm a Southwestern Ohioan. This is the mound there in Miamisburg several years ago. But when I was young, we moved to Miami, Florida. I was about 3, 4, 5 years old before we moved back. And really became hooked on weather then because of tropical systems. This idea that these tropical systems come by and the atmosphere interacts with the ocean, and I was just hooked. A year after we returned to Ohio in 1988, we had the big drought across much of the country, including Ohio. That was enough agriculture for me in terms of a career. This is my retirement photo here in the bottom left. The last time I was on a tractor, actually, but I was sort of always interested in agricultural science, but more so in the weather. So this opportunity that I have now to travel the state and talk about the intersection of weather and climate with agriculture really is what I feel is my home. It's really a place that I feel like I belong. So there's several questions, kind of broad questions. I want to just really whet your appetites today. Just thinking about the local changes that we're seeing. I want this to be a personal story. I want you to feel personally connected to the changes that are taking place on this land that we share, and how that impacts what we're trying to do from an agricultural perspective. So first, what are those local changes? Now, I always, if you've seen, I know I recognize a few names in the chat, in the participant list. If you've seen my talks before, I always talk about weather and climate and the differences, because it's really important to start there. And of course, weather are these really high frequency, rapid changes in temperature, pressure, wind speed over short distances in time. And sometimes when we're living these experiences and sensing these things, it's really difficult to pick up on patterns. So as meteorologists, we like to zoom out, look at broader patterns. This is an example of what we might do. We look at the entire world here for an arbitrary month. It's April of 2013, and we watch the cloud patterns moving across the surface. Right? So here we have these cloud patterns moving across, and I say patterns because it doesn't take long to see those patterns, the rapidly moving clouds across the bottom part of your screen, or they're moving in the opposite direction at the equator. All of those high frequency, very fast changes in the weather all settle into these longer term patterns that we call weather patterns. And those weather patterns over a longer period of time establish our climate, what we expect. It's those averages over longer periods or more. So, I always like to show this video. This is a metaphor for how we can think about weather and climate. Now, we're just out walking our dog, right? The dog's on a leash, but that dog is driven by some natural tendencies. That dog has to use the restroom and it sees a fire hydrant. We always call that P mail. But anyway, that dog's moving back and forth and some chaotic motion. And at any point in time, the dog can be moving in the opposite direction of the dog walker. Okay. We still expect them both to be in that general direction, that same location in a couple of minutes. And that's based on the path that we see the dog walker taking. So even though that weather, sorry, I let the cat out of the bag, no pun intended. We let that dog moving back and forth here, that chaotic motion, they still generally move together. And we can describe that mean path of the dog by the dog walker path. So dog is our weather, okay? And the dog walker is the climate. And even though they're related, there are differences. And at some points in time, we can have record highs during cool summers, record lows, record warmth during cold winters, vice versa, right? We just went through a big change of near 0 degree temperatures here in Ohio to now we're up near 60 degrees in some places, right? So rapid changes. We won't see those in the climate records because those means really average out over longer periods of time. So thinking about that now, we do a global climate assessment and we think about how things are changing from a broader perspective first. 2020 was our second warmest year on record back to 1880. Going back to 1880, since 1880, 2020 was the second warmest. It was only behind 2016 by 0.04 degrees Fahrenheit. So statistically, they're the same. They're just as warm. And 2019 is now the third warmest. And in fact, if you look at the top 10 warmest years, they've all occurred since 2005 for the globe. Okay, so this is undoubtedly, we're warm. We're warmer than we have been at any point throughout the 20th century and much of the latter half of the 19th century as well. And if you were born after 1985, February 1985, you've never experienced a cooler than average planet for the month, or cooler than average month for the planet. Okay, 1985. So that's been quite a while since we've had a cooler than average month for the planet. But why does this matter? Well, there's a couple of key greenhouse gases that we pay attention to, CO2 and water vapor. Now, water vapor is the most abundant. It's not the most dominant, but it's the most abundant greenhouse gas source that we have in our atmosphere. And combined, water vapor and CO2 keep our atmosphere 60 degrees Fahrenheit warmer than it would be if we did not have those. So clearly, they're critical parts of our atmosphere. But they don't care about the shortwave sunlight coming down from the sun. They care about that long wave infrared radiation coming off the Earth's surface. So as those greenhouse gases absorb that energy, it keeps our temperature warmer. But the more of those greenhouse gases we have in the atmosphere, the warmer the atmosphere becomes. And in transition, or I should say, coupled to that, the warmer we get, guess what? The more water vapor we have in our atmosphere as well. So what we see is an intensification of our water cycle, where the warmer temperatures lead to more evaporation, more evapotranspiration, condensation, clouds, more precipitation, heavier downpours, right? And so we intensify both sides of this hydrologic cycle so that we can actually get intense shortages of water during our most intense part of the growing season, the warmest temperatures, but also these extreme heavy downpours. So we're intensifying what we call our hydrologic reality. And of course, I talked about how personal things are with climate. We have regional impacts across the US, right? Heat waves, wildfires out west. That's really what they're bearing in terms of the climate changes we're seeing. So it brings up this idea that we've got to manage our resources in a very thoughtful and careful way, because climate is challenging our stewardship of our resources. If it's out west, it's timber, right? If it's in the southeast, we're trying to build resilience to the strongest hurricanes that are increasing in frequency, right? If it's across the Midwest and the Northeast, it's these intense heavy downpours. But also, I would add those seasonal water shortages during the height of the summer as well. So what we call climate change is a threat multiplier, okay? It makes everything we do harder to do, right? We saw that with the vaccinations this, earlier this month, how much that highly variable weather, that extreme weather pattern that we saw, which is driven largely by the overall climate changes that we're seeing, how that can then impact a health scenario. And we see that from health to transportation to many other sectors. And so it's a threat multiplier. That's how we look at climate change. We can look at our billion-dollar weather and climate-related disasters from 2020. We had 22 of them. Okay, the highest number we'd seen previously back to 1980 was 16. But all of the lines that you see there at the bottom, these are all the years since 1980 of billion-dollar weather and climate-related disasters accumulated throughout the year. So the far right is the total. And a lot of years in the recent decade have been toward the top of that graph, all of the different colored lines that you see. The 1980 to 2020 mean is the black line that you see around 6 events for the last 40 years. Okay, these are all consumer price index adjusted, so they're on the same scale. We've just seen a lot more of those. And from an Ohio perspective, we're likely to see these through a rain interface or a precipitation interface because we're a water-rich area, right? We're not dealing with water rights and water shortages anywhere near like they do out west or other parts of the world. We're a water-rich area. So most of our natural disasters come from those rain and rain-related disasters as well, right? So this is that water-rich interface that we see in Ohio. So let's look at some of the seasonal changes that we've seen close across the U.S. and closer to home just since 1990, looking at changes over the last 30 years. And the seasons that you see here are winter, spring, summer, and fall. You see warming generally in spring, summer, and fall, but there are some regional differences around Ohio, okay, just in the last 30 years. Of course, if you're looking at longer term changes from the middle part of the 20th century, some of these are even greater. But if you're looking at that spring warmth and the fall warmth, that's what we're seeing here in Southwest Ohio. Temperatures that are about 3 degrees warmer during our springs and falls than we saw since 1990, a 3-degree increase over that 30-year period. There's some capping on the summertime, right? Which is interesting. We actually see fewer 100-degree days than we saw in the early part of the 20th century. Again, because we have more water vapor in the atmosphere, which limits our daytime heating, but it warms our overnight lows because that energy can't escape to space at night. So for instance, if you look at the autumn overnight lows, again, we've seen anywhere from 3 to 4.5 degree Fahrenheit warming just in the last 30 years across the state. So big changes with our temperature. Similarly, if we look at our precipitation again, all seasons here, we're getting wetter locally. So if we look at winter, spring, summer, and fall, there's some regional differences if you're looking at particular stations, but generally all of our seasons, we're getting more water, especially in fall, winter, and spring. the off season. During the summer, what's interesting is even though overall we're getting increases in precip, there's a lot of areas, for instance, on the right-hand side, you can see the July trends that are actually decreasing in precip. So even though the summer is wetter, the height of that warming during July with warmer temperatures, very strong evaporation, leading to these big changes in terms of a kind of a, even though we're getting wetter during summer, we're still dealing with droughts and water shortages at the height of the season. So how do we manage that, flipping back and forth between these extreme hydrologic realities? And of course, again, just proof that our heaviest precipitation events, the 2 to 3, the 4 inches per hour, are increasing. They've been increasing since about the mid 1990s. There's nowhere else in our record that really challenges what we've seen of late, except for maybe 1913, the period around 13, 37, and 59. And those were all major flood years in Ohio. So the point of the graph on the right is that we're never far away from a hydrologic natural disaster when it comes to these extreme precipitation events. Okay, so very, very important. So, if you rank the top 10 wettest and top 10 warmest years in Ohio's history back to 1895, 8 of each of those have occurred since 1990. If you look at the precip recently, 17, 18, and 19 are all in that top 10. 2020 was actually the 29th wettest, even though we had drought conditions over 38% of the state last year at the end of July. So again, just driving home those extreme variations in our weather patterns. And where we expect to go into the future is much of what we've seen with warmer winter and warmer nighttime temperatures. By mid part of this century, 2050, we're looking at an average of 3 to 5 degrees Fahrenheit warmer than our contemporary climate. It could be as much as 4 to 8 degrees Fahrenheit warmer for that average temperature by the end of the century. And again, changes in precip are driven by increases in water vapor, higher humidity, right? Seasonal changes where we get more fall, winter, and spring rainfall, but less during the summer. Our trends show us in the future, we're likely to see continued decreases in summertime water availability, right? Intensified drought. So again, it brings back this idea of how do we manage all of these resources from a very sound stewardship perspective. So I always say, I like to use this graph because it really shows Ohio's climate's on the move. We're already moving even past what's illustrated here, beyond what's illustrated here. If you take a 2003 Ohio kind of contemporary 1976 to 05 average, we're moving toward, by the end of the century, a North Carolina winter and an Arkansas summer. Agriculture is not going to look the same here in Ohio with those types of conditions, right? Where we've got a very hot, dry summer, but we've got very wet autumn and spring. What do our crops look like? How are we covering our fields? What are the types of management practices should we be doing at all scales of agriculture, right? From small gardens to larger plots to urban ag, all of these things come into play. So really the next broad question is how does all of these things affect agriculture? Okay, there's a lot of impacts and I'm going to go through them, and there are some benefits and there are some not so great things on the horizon, or things that farmers are already dealing with. All of these, there are a lot of issues here that are already being voiced by farmers all across the country in terms of that climate threat multiplier that we see. So we think about those increasing temperatures, additional sustained heat stress, longer heat stress in earlier part of the season because of higher humidities. That's just not on humans, but also livestock, and different animals that we have. We think about those warmer nighttime temperatures in the summer, actually pushing the energy use, right? The phenological states of our crops, perhaps reducing the quality of those crops. We think about warmer winters and increased weed and insect pressure, multiple generations of insects, potential disease, more wetness leading to more fungus and more disease in that regard as well. Not just in the rural areas, but also if you think about the heat in the cities, right? And from an urban ag perspective, for instance, downtown Columbus can be upwards sometimes 24 degrees warmer than the outer belt, right? 24 degrees difference between inside the city and outside the city. On average, it's at least 4 to 5 degrees warmer, and that can have impact then on our urban ag settings, and something to consider. We know that with our increasing temperatures, we've seen the shifts in our growing zones. and unpredictable growing seasons, extreme temperature swings. March of 2012, 85, 86 degrees, a string of days with freezes that still return in April, and I'll get to that in a second. Non-native plants and animal ranges expanding and outcompeting because they thrive better in the conditions that we're moving toward. And so when we think about our native and iconic plants and even horticultural perspective, those things not able to survive quite like they could perhaps in the 1960s or 1970s. Benefit of the increasing temperature, longer growing season, right? Maybe I can grow new crops, but are they going to survive 3, 4, 5 years out of 10? We still have those extreme variability. We still have our polar vortex events bringing down the colder air, but we know our growing season, just defined by temperatures, is lengthening, right? Some places of Ohio, even 15 days longer than 1970. If we look at our warm Februarys and Marches, 4 of the warmest in Ohio have occurred since 2000, 2012, 17, 2000, and 2016. Okay. Probably not this year, given the cold conditions that we had in February, but it was a very warm winter leading up to February, and March looks very warm as well, right? What does this do? It creates fall springs, plants bloom earlier, creating unpredictable growing seasons and disconnects with our pollinators. These are big issues that we have to deal with from a temperature perspective. Precipitation impacts. Obviously, the big one is a greater risk of floods. But what does that do? Not just flooding our fields, but damages to all of our water infrastructure, changes our floodplains, right? Any of the municipal flood walls or dams and all of that stuff, water intakes are potentially impacted. Health risks, transportation issues, areas not able to get your crops transported to elevators, for instance, if you have more flooding and things like that. And again, these extreme switches between extreme water and extreme drought as well. So, all of that intense rainfall leading to more runoff and potential contamination, nutrient loss, and again, those water shortages potential in the height of the summer. So there are a lot of different impacts that are certainly impacting our farming and our agriculture, impact on our soils, right? It really starts at our soils, thinking about how increasing temperatures and the loss of organic matter, increasing rainfall, which can increase productivity, we know that. But what about the enhanced surface runoff, the nutrient leaching, right? All of these different compounding issues, none of these exist in isolation. We have to look at them from a broader picture and weigh the pros and the cons from a management perspective. So we think about our healthy soils. How are they being impacted by our climate change, erosion, compaction, loss of organic matter? All of these things should be central, I think, to a management strategy of how we overcome and perhaps build some resilience. And there are a lot of farmers that are already committed to things like no-till, committed to cover crops and things. I always say I'm a climate scientist. I have the easy job of talking about weather and climate. Farmers have the hard job of deciding how to manage all of these things together. But I think it takes both of us having these great conversations that can help one another. I was asked to think a little bit about OSU and doing, what are we doing to adapt and mitigate the climate change? And I certainly cannot represent the entire university. I'm just one person. And there is research taking place all over campus for different areas. I come from the Byrd Polar and Climate Research Center, so we do a lot of global investigation of temperatures and precip across the entire globe as well, thinking about climate change. I'm part of the State Climate Office of Ohio. We've developed Columbus's climate adaptation plan, but also provide some weather and climate services that feel free to visit the sites and partake there. We have a Sustainability Institute at the university, working on ways of building resiliency from urban to rural areas and different techniques as well. We have the Carbon Management and Sequestration Center, which was recently named for Ratan Lal, distinguished professor who won last year's World Food Prize. So carbon sequestration, I think, is vital as we head over the next 10, 20, and 30 years. We have to be part of the solution to climate change. Some of my own kind of outreach and research is really strongly with OSU Extension. We have a weather extremes team now addressing some of these issues from production and the like, research dealing with weather extremes. Reaching out and working regionally and federally, I work really closely with the USDA Midwest Climate Hub, and I'll talk a little bit about those in a second. Working with NIACS, the Northern Institute of Applied Climate Science. They have a course designed to help professionals, and a few of you on this call today are participating in that class this winter and spring, to integrate climate change considerations into real-world natural resource projects. I'm involved with some modeling aspects where we take climate and farmer decisions and ecosystems and the economy and policy and think about, how farmers are likely to adapt to these climate-induced risks. What are the best policies, right? We know that markets and policy, we know that markets and crop insurance really help at times limit the risk, but what are we looking at as we move into the future? I think those are some really important questions. And I know I'm getting close to the end of the time here. We wanted to wrap up, but let me go through this last piece, which is, what do farmers need to grow to cope with climate change and make more money? I'm going to combine this with the USDA question of, what can the USDA do? And first of all, I can't tell anyone what crops to grow because, again, it's a local management issue. It's what is your field, what is your living condition, and what types of risks are you willing to take on? So it's a very personal challenge. But I hope to give some tips in terms of things I think we can think about from a holistic approach. I think it always starts with talking about it. We've got to talk about it. We've got to talk about how big of an issue this is. We can't be afraid to be talking about this with our family around the dinner table, our faith communities, any identity that group that you identify with can talk about climate change because it just filters into everything we do. We know that it's happening. We know we're experiencing the effects. We know that we're the cause of what we're seeing today. The scientific evidence is overwhelming, but there's something we can do about it. And we have to, because if we're not adapting and we're not mitigating, we're going to suffer. And the poorest and most vulnerable are going to suffer the most. And so it's very important that we take this kind of stance. I did want to provide the USDA recently put out their 2020 to 2025 science roadmap for those that want to read a little bit more about how they're gearing their research over the next 5 to 10 years, really over the next 5 years. The top two, theme 1 and theme 2, are sustainable ag intensification. What does that mean? There's a lot to unpack there, but also ag climate adaptation. Right. So these are very important from a USDA standpoint. And I think with, the recent appointee being Vilsack with the USDA, there will be a lot of emphasis put on climate change. There's the Growing Climate Solutions Act that you may or may not be familiar with. That really is designed. It's in the House Ag Committee still right now. Creating certification program to help solve those technical entry barriers to participating in carbon markets. More website, more transparency about regenerative process and how to monetize, and creating reports to Congress and communicating with agriculturalists on these issues. So there's a link there to more information about the Growing Climate Solutions Act. We have a fantastic resource in the Midwest called the Midwest Climate Hub. Their vision really is robust and healthy agricultural production and natural resources under this increasing climate variability and climate change. With the State Climate Office in Ohio, we work very closely with this group out here to think about outreach and engaging in the community. But there's a lot of resources and webinars coming through these hubs that can really help everyone on this call today. And I would love to spend the next, half hour, 45 minutes just breaking down those strategies. And again, I don't want to be prescriptive, but really the question I think we're all at right now is, so what now? Okay. There is a great resource for adaptation called the Adaptation Resources for Agriculture, again, through the USDA and the Midwest Climate Hub. Again, if you're working through the NIACS program right now, we're going to really dive into this a little bit, but it's based around 8 strategies. And I just think you'll see those common themes that I talked about: soil, water, risks of warmer, drier conditions, managing farms and fields as part of a larger landscape. I think a lot on this call are really focused and thinking about that, and certainly Agraria Community Solutions and the Tecumseh Land Trust are thinking about those as well. So this is a fantastic resource, and maybe we can get a little bit into it in the panel as well. So with that, I'll go ahead and conclude today. I always like to provide my motivation for talking talking about climate change, and I can't think of any two better examples than my two daughters here, and constantly thinking about their future and what they're inheriting and what we can do to help out the situation in the future. So with that, I will turn it back over to Krista. Thank you.